All right, this is section 2.7, linear equalities and absolute value inequalities. Part 2 video. We're going to solve this particular inequality. One, it's a compound inequality because there's two inequalities there. And this particular compound inequality is an and. Okay? It's an and because the way it's formatted. All right? Now, so this is how you're going to split it. Okay? So you're going to take negative 10 less than equal to negative 4x plus 2, and then you're going to take negative 4x plus 2 less than 6. Note that the middle part is in both of the equations. Okay, the middle part's in both of the equations. So let's just solve them from here. So negative 2, that gives me negative 12 less than equal to negative 4x. And of course, we're going to divide by a negative, and when you divide by a negative, it's going to flip the inequality, and you've got that. Okay, now I'm going to turn around and rewrite it such that the inequality, the variables first, because that way I know that the inequality points in the direction that the line needs to go. Now, I didn't change anything from the black to the blue right here. The only thing that I changed was x and the 3, and then I made sure that the 3 was being eaten by the inequality. Okay, so you can do that. Now, minus 2, so negative 4x less than 4, divide by negative 4, and I got x is greater than, I got to flip that inequality, right, because I've divided by a negative, and that's negative 1. All right, so when you graph this, I need you to understand something. This is negative 1, it's going to be an open dot. That is 3, that'll be a closed dot. Normally you go, they're like this and they're like that, right? Not true for an and. They are, but for an and, it's only where they touch. So if you looked and sandwiched those together, if you press those together, the only solution would be writing there, okay? So where you go to plot this, you're not going to have it going on past on both sides. No, you're going to just have that area connected because that's the only region that is the solution, okay? So that's how you work an and. Now, let's look at this one. All right, so we're going to look at some absolute value equations, okay? And they are going to be written as compound inequalities. So when you have an absolute value isolated, meaning just the absolute value bars and everything inside it, nothing else on the outside, so on one side of the equation that's isolated, read the inequality. If it's great or greater than 4, great or, if it's greater, then it's an or, you hear the or. And then the other one would be if that is less than, and that would be an and, right? Compound inequality. So that's how you read those. The absolute value has to be isolated in order to read it. So if you have to do some adding, subtracting beforehand, maybe even some dividing to get the absolute value by itself, then that's fine. But only then can you make the determination if it's an and or an or. So when you do an absolute value, you actually have two equations. You have a positive equation and you have a negative equation. Okay, the positive equation is exactly what is there. All right, and the negative equation is the variable or whatever's underneath the or between the absolute values. Flip the inequality and then multiply the right side by negative 1. So that would be negative 4. Okay? So we've already said this one is an or. So we're going to say x is greater than 4 or x is less than negative 4. All right? So that's the inequality. Now, for the interval, how we're going to do this is pretty simple. We're going to have open dot going this way, and we'll have a open dot going this way. So that's negative infinity all the way to negative 4, and that's parentheses because open dot. u, because there's a break, and then we'll start back with parentheses 4, comma, infinity. So that's going to be the interval notation that is written there, okay? That will all go in there. Now, here's one, absolute value greater or than 3. That's an or, okay? So we'll write a positive, and then we'll write a negative. We're going to put this answer as an interval, so everything, just like it says, will be the positive. And then the absolute value content, then we're going to change the inequality. See how we changed it down there? It was greater or, we changed it to less than, right? And then multiply the right side by -1, which would give that 3 times -1, -3. So we're going to minus 2, so x is greater than 1. We're going to minus 2, and x is less than -5. All right, so we're going to quickly do an Etch-a-Sketch, quick little number line, okay? We've got -5, we've got 1, x is greater than 1, so it goes this way. X is less than -5, it goes that way. So our interval is going to be negative infinity all the way to -5, parentheses, u, 1 to infinity, okay? 1 to infinity with parentheses there, all right? Now, let's look at this one. Let's go back and look at this one. We've got to adjust some things before we actually start to solve or split and do our positive and negative. So let's take the 4 over. So that's going to give me 5 times the absolute value of x plus 2 less than or equal to 25. And then I'll divide both sides by 5. So that's going to leave me 5. Nope, sorry. Absolute value of x plus 2 less than or equal to 5. Okay, so I'm going to, again, do my positive equation and my negative equation. Note that the negative, the requirements for the negative is bring down that absolute value, flip the inequality, and multiply the right side by -1. Okay, so that for the positive, that's the way it is. And for the negative, we're going to flip that and make that a -5. Okay, now we're going to solve. Just a quick little solve this, little one-step, two-step equations, right? Now let's graph it. Got my negative infinity, got my positive infinity. I got a -7 and I got a 3. Let's see, -7. Oh, I didn't even look to see. Let's see, hold up. This is absolute value less than 5. So that is an and, okay? That's an and compound inequality. So we're going to go this way, and then we're going to go, oh, you make those solid, and now we're going to go this way, all right? But the answer is only right in here, correct? So in doing that, just so you know, when you graph it on the computer, you're going to only show,
I need Brianna to come in.
You're only going to show -7 to 3, okay? If you show other than that, then it would count it wrong. But the and tells me that, okay, my answer is only where they touch, all right? All right, so let's do this one. So we're going to add 2. So that is 3, absolute value of x minus 5, less than or equal to 3, divide by 3. So absolute value of x minus 5 is less than or equal to 1. Less than, it's an and, right? Okay. So we're going to now solve it. We're going to write a positive, and then we're going to write a negative. Okay, so that is x minus 5 less than or equal to 1. X minus 5 greater than or equal to -1. So I'm going to add 5. So x is less than or equal to 6. Add 5. X is greater than or equal to 4. All right. So we're looking at this. Let's see. 6 is going to go. It's going to go this way all the way down to 4, and it's only going to be between here, right? So that's the solution. All right. One more. And that'll be all for this particular unit, okay? So, again, we're going to -2. We're going to isolate the absolute value, we'll divide, right? So be careful, because this right here could be a negative division, which would flip that, okay? So that's x minus 5 greater than 3. That's an OR, right? Great OR. Did you hear that? Greater, great OR. So we're going to have a positive and we're going to have a negative, okay? For an OR compounded inequality, it only has to work in one of them for it to be a solution, okay? So it's this one or that one, and it'll explain more when we get to the graphs, okay? So x minus 5 greater than 3, x minus 5 less than negative 3. So we're going to add. So x is greater than 8. We're going to add here. X is less than 2. All right? So we're negative infinity, positive infinity. We've got 2. We got 8. Now let's see. X, let's go. That's going to go. It's an open dot going that way, and that's an open dot going this way. So the solutions for this is negative infinity to 2, u, 8 to infinity. Now notice that solutions can be all in this area right here, and they can all be in that area. Okay, they don't have to be in the same time. X is in there or X is in there. So that's what an OR is. An AND means it has to work in both of them for it to be a solution. Okay, so this concludes section 2.7, linear equations and absolute value inequalities, part 2 video.